2. Okay, so now we're doing some new integrals. These ones all have trig functions. And so the first thing I'm thinking is probably trig integrals. So first, integrate sine squared of x dx. And this is a good thing. It would be good to have a whole bunch of trig formulas on your formula sheet, because if I just try to do this, maybe I try some weird integration by parts thing. Maybe that works, maybe it doesn't. But what would be way easier is to know this formula. Sine squared of x is 1 minus cosine of 2x over 2. So now this integral is actually the integral 1 minus cosine of 2x and then over 2, so that's really a 1/2. So I can pull it out in front of the integral. Okay, but then this is 1/2, and the integral of 1 is x. The integral of cosine is positive sine, but because of the 2, I need to pull a 1/2 out front. Right? Again, that's a simple u substitution where you let u be equal to 2x. And then if I expand, I get 1/2 x minus 1/4 sine of 2x, and then plus c. And that's my answer for A. So knowing those trig formulas really makes it significantly easier. So part B. Now I have the integral tan cubed of x secant of x dx. So the question is, first maybe the rules for tan and secant say, should u be tan x or should it be secant x? So if u is tan x, then I would need a secant squared. I don't really have one of those, and it would be hard to get at one. So the other thought is to make u secant, in which case du is secant of x tan of x. So that's what I'm going to aim at. And this problem throws a little bit of a wrench into this. Secant x tan x. Because if I pull out a secant x tan x, then I have tangent squared of x times secant x tan of x. So I successfully pulled out the thing that's supposed to be du dx. It's pulled out the thing that was supposed to be du, but now I don't have any u's. But secretly I do have some u's, because tan squared is really integral secant squared of x minus 1. That's another trig integral, or trig formula, and one that's going to come up, times secant of x tan of x dx. Okay, and now all of a sudden I do have some u's, right? So this is the power of these trig formulas. So now this is the integral of u squared minus 1 du, using this u equals secant x, and du is secant x tan x. But integral of u squared minus 1, that's a pretty easy integral. This is u cubed over 3 minus u, all plus c. So that is our answer for part B. And now finally, we do one more, C. And that is the integral of sine squared of 2x times cosine of x. Okay, so again, this is one trig formula magic that needs to happen. Sine of x, or sine of 2x rather, is equal to 2 cosine of x sine of x. So then this integral becomes, use this formula to bring the powers down, sine of x cosine of x squared times cosine of x dx. And now all of a sudden, I get 2 squared is 4. Integral, I'm left with sine squared of x cosine cubed of x dx. So what do I do here? So the strategy for picking whatever sine or cosine should be you is pick the one that has an odd power. If both of them have an odd power, then take your pick. So here I let u be equal to cosine of x, in which case, or set it backwards, let u be equal to sine of x, then du is cosine of x. So I'm left with 4 integral sine squared of x. I peel off one of these cosines, so it can be a du. And so what do I do from here? I say really, in reality, this is sine squared of x, and then cosine is 1 minus sine squared of x dx. And so, except I forgot the cosine, the whole reason that I did this. And now everything's in the form of sine, so I can make this 4 integral u squared 1 minus u squared du, because cosine dx is du. And so I get 4 integral u squared minus u to the 4th du equals 4 u cubed over 3 minus u to the 5th over 5 plus c. But then remember, this was sine the whole time, so I have 4/3 sine cubed of x minus 4/5 sine to the 5th of x plus c. And that is it for problem number 2.